Hello, Flat Earth researchers, debaters, and debunkers. The air above us and the water having a pressure gradient is often used as an argument against the flat Earth or some kind of proof of gravity. It's assumed that this force of gravity is required for a pressure gradient, and so it's often cited as proof that we live on a globe. But is having a pressure gradient really an argument for living on a spherical Earth? So what I'd like to focus on in this presentation is defining the cause and effect of pressure gradients. And of course that involves talking about the definition of gravity. So we need to look at what actually causes pressure gradients or varying density in gaseous and liquid mediums that we see and we can, to a certain extent, measure on or above the Earth. And of course, what causes gravity, what is actually being measured. And there is a difference between measuring the weight of something and this alleged force of gravity as an external force. So I'm going to blab on for about 30 minutes, raising different points and different aspects in no particular order, but I will summarize this with what I hope are some clear, definitive points to consider about what we can or cannot prove about the causes of pressure gradients and gravity, and what we can or cannot measure, and what is assumed for any particular model, especially the globe model, and the connection that's made between the observations we can make on the Earth and the measurements we can make on the Earth compared to the observations that we can only make when it comes to looking at celestial objects, the sun, moon, and stars, and the so-called solar system. So I will summarize all of this in the end. There's no denying that there is a pressure gradient. It is as it is. The science, the physics is there that demonstrates that there is a pressure gradient. The higher up you go in the air, the less pressure you feel. The deeper down into the water you go, the more pressure you feel. And this is said to be because of the alleged force of gravity. So let's just discuss a few of the points here and see whether the pressure gradient really is any kind of argument at all. Because ultimately what we have to talk about is the mechanism, what creates this force, so say, of gravity to allegedly pull down air molecules or the water and create that pressure. Is it a force coming out of the Earth and pulling everything down? So, just to be clear, it's acknowledged that there is a pressure gradient, and naturally you can calculate a point where there will be zero pressure. So you then naturally have a vacuum. There's nowhere left to go mathematically. So again, there's no argument there. It's just demonstrated as a physical fact as far as we can get up and measure. But is it at all possible to go beyond that point anyway? Is that perhaps the limit of where any spacecraft or space exploration has ever been? Just not beyond the dense atmosphere, because we know that even aircraft, the higher they go, the less dense air becomes, and eventually the aircraft stalls. It can't fly. It can't create any pressure under its wings, and the engines fail, and it can only come down and begin flying again because there's more air pressure. A soupy mixture of air to push off. It's really no different to being in a liquid. It's just like a less dense liquid, really, isn't it? So there's that to consider. Maybe that's as far as we've ever been, or been able to see or measure, whatever. But of course the question is, what's after that? Is there anything above that? Because we know that nature abhors a vacuum. And in the natural scheme of things, without any gravity, hot and cold air circulate, and they create dense and less dense air, and this is a kind of yin-yang thing. There's one causes the other. You can't have one without the other. So although hot air is less dense and cold air is more dense, yes, it's the cold air that falls down and the hot air rises, it's less dense. So there's only temperature and density going on. Gravity just isn't part of the equation when it comes to the rising and falling of air due to its temperature, or the pressure of the air because of the temperature. And then we have the fact that gases within the air, the lighter gases, will rise up, such as helium. So does it not make sense scientifically that you will eventually get layers of thinner and thinner gases that have risen up? So if the air comprises nitrogen, oxygen, and all these other gases, then, okay, down here we have a mixture, but is it not logical that eventually you get layers, just as we see on Earth? It doesn't change, nothing changes as far as the physics goes in that respect, but you get layers and layers of less and less dense gases. So of course the argument is usually that one of between having a dome, a physical barrier to create the divide between the pressurized system and the non-pressure of a vacuum. And of course we know how difficult it is to create that separation on Earth with a vacuum of zero density. It must be in a container for that to happen, for there to be any difference in pressure. So while mathematically we can calculate a point where the density reaches zero and you then have a vacuum, but then in the real world of physics you do need that separation. As we said, nature abhors a vacuum, and regardless of gravity, any kind of pulling or pushing force in any direction, gases will naturally dissipate within a medium. And again, of course, we're talking about different mediums that are liquidy, gassy. They're very similar, it just depends on temperature. So this is another thing that comes into mind when we consider the physics of it, and especially that we're talking about the difference between accidental occurrence of life on a spinning ball rock and some kind of intelligent design, benevolent or otherwise. So we're not really talking about God or a creator as a persona or spiritual entity or all-seeing benevolent being, but there is intelligent design for this place that we live. The how and why of that remains a total mystery, so that's not even part of the scientific inquiry, but it's obvious that there is intelligence in every form of life that we can see. And it appears that a lot of intelligence creates this beautiful balance that we have of constant change, keeps us sustained. So the point I was leading to there is that the sun doesn't have to be this big ball of fire 93 million miles away. If we think about the way a magnifying glass focuses light, something similar could be going on with the sun as it shines on the earth. And so it wouldn't be hot high in the air above the earth, because the light is not focused on that point. It's just a broad swath of light. The more focused the light becomes, the hotter it becomes. Just like we've all probably done with magnifying glasses burning leaves or ants or whatever. We know this. It's something we can do. It's physics. And we know that a slight tilt will kind of defocus that beam to take it from being a circular focal point to an elongated one. So this would quite easily be another demonstration that we can do in real life of how we see the pool of the sun's light stretching across the earth, very intense around the equator where I am, and getting weaker as it goes out towards the north, to Europe, the colder countries. And so just a slight tilt of this focal point of light would be enough to generate a difference in the time of day in the northern regions, or the temperature. So in Phuket right now it's scorching hot. It's very dry heat, so it does feel like a very direct heat. And this is beginning of March the 2nd. It is today, or 3rd. So during this time is when it is at its hottest, and it carries on like that until April, while of course over in Europe it's very cold at the moment. So this can be explained, can't be proven, but it can be explained in the same way that we would tilt a magnifying glass to change the strength of the focal point that we're directing at the Earth. The space or the air between the magnifying glass and the Earth doesn't get hot because the light's not focused on it. So this means that whatever or wherever the sun is, it may be possible that it simply just gets colder as you rise in altitude. So if you have the light gases, the less dense gases, naturally rising in layers, then, for example, helium, then you would eventually get, maybe if it gets cold enough, you would get liquid helium. And then if it gets even colder, you get ice, helium ice, becomes a solid. And as far as I understand, helium, it doesn't give any friction. So something could easily glide through helium as easily as a vacuum. So this brings us around to the whole concept of the globe Earth model, the heliocentric model. And of course, a vacuum is something that's required to go along with the notion that all the stars and the planets are bodies of mass, and so they are all falling through empty space or falling towards a sun in circles, perpetual circles or orbits or elliptoids, whatever. The point being that, of course, someone like Galileo did experiments with marbles, and he was possibly one of the people to conceive of the idea that up there in space it is a vacuum, and that's what you would need to have everything just spinning around without any friction. So it becomes a good idea for the heliocentric model, which again is all based really, or has to have the assumption that everything we see in the sky is a ball of mass, and that we are another ball of mass, another planet. Just puts us among them and the sun at the center. So of course then the connection is made. The connection between dropping a mass through the air on the Earth, which takes a certain time to accelerate over a certain distance. And then we are measuring what we call gravity with the passage of time. So we have a constant now, a constant attached to this idea of gravity, which really the meaning of the word gravity only means weight. That's all it means. Remember, what we have to ascertain is the mechanism, the cause of a mass having weight in the medium of air on this Earth, or in the water, wherever. So it is understood that if you perceive the Earth being in empty space, or that the Earth has a particular spherical mass, this gives us a number to work with, and we can assume that it is the mass of the Earth creating this external force to pull everything towards the center of this spherical mass. So the model is very well understood in that respect. It makes sense, and really nothing changes, as I mentioned earlier on. The pressure gradient is there, it doesn't change, but it doesn't dictate that we are on a globe. It doesn't dictate that the mass of the Earth, and the Earth being a spherical mass, creates any kind of external force. Of course, it's understood that you need an external force to push something along, like a car on the road. Yeah, you push it along, and if you have wheels, then you don't get so much friction. Of course, if something weighs 10 kilograms, then you need 10 kilograms of external force plus a bit more to compensate for friction to push that 10 kilogram object along, because it's already on the floor, isn't it? It's already at rest, as they say. But of course, the language of physics has been adapted to say that it's still attempting to accelerate towards the Earth, but it's not accelerating anymore. So again, it's the rate of acceleration, the time it takes for an object to fall through the air, regardless of when it hits the ground. The rate of acceleration is what's used, this 9.8 meters per second, as a constant. Just call it 10 if you like. So this constant is referred to as gravity, and the fact that something will fall through a vacuum appears to prove that there is this gravitational force. But the thing is, you're still putting something, even if it's a feather, you're still putting something that is a dense mass into a completely empty medium. So it will fall. Again, it doesn't prove in any way, or there is no proof in any way, that it's the Earth being a spherical mass that creates this force. And of course we're taught to consider that it's an external force, because that's what we have to do if we want to push something along, or even push something up into the air. We have to use an external force to push. However, something having mass means that it has the force is an internal thing. You don't need an external force for a mass to fall. But a mass can also rise. For example, a helium balloon is a mass, because it's a gas contained in a container, even though it's elastic. So then you get an upward force because of the relationship between the mass and the medium. The medium can expand and go around it, but the mass must pretty much remain its own fixed shape. So something weighing 10 kilograms has the force of gravity, weight, inside it already, in its mass. It doesn't need anything else, and it's only because of its relationship with the air. And so if we put a helium balloon, for example, in a vacuum, then it will fall because now it has more mass than the medium around it, which is a medium of zero density. So even if it weighs a tiny bit more than the zero density environment around it, then it's more dense, simply more dense. So it just gives us a universal up and down on the Earth. Again, it's all understood that if you're in space, there is no up and down, and you can have down going towards the center of a spherical Earth, and therefore that's always your direction of down. Absolutely understood. And of course, it's also understood that if you consider that you have an empty space, a vacuum, as it were, zero density, no friction, if you want to perceive this, then to push a 1 kilogram block around does require 1 kilogram of force in any direction, because there is no up and down anymore. But this is just a concept. It's just an abstract thought experiment. Doesn't mean that's what's happening up in space, but of course it's a concept or a perception that fits well with the heliocentric model and the idea that all these big, huge planet-size masses are being allowed to just circulate without any resistance. So really back to the point that this was the connection made. The fact that something will fall through the air was then, with a known constant rate of acceleration, this was then used, because it was talking about time, to make a connection to the heavens, the stars and the planets all moving around. And of course, the one thing that we can measure is the time it takes for something to do an orbit, whether it's around the sun or a moon around its planet. We can measure the time it takes, and that's all we can measure. And from that, we can then use our assumed mass creating gravity model. Then we can create, or we can calculate distances, speeds, sizes, masses, the alleged gravitational pull based on the mass. All that jazz can be calculated once you have your constant, your standard, the 9.8 meters per second, or 10 pretty much. It's just everything's founded on 10, adding or taking away zeros, because you're starting with the foundation of the measurement being on Earth. So of course, it's well understood that this is why you might bounce around on the moon, because the moon's smaller, has a less mass, etc., etc. So, there is no disputing the mathematics or the calculations that will work for the model. They will all appear to fit together, as it were, as long as you say, well, that planet over there has this kind of mass, and this one has that much mass, or this one looks bigger, but etc., etc. You just make up explanations as you go. And you can even say, well, we know that 2 gazillion tons of nickel will weigh this much, so we'll stick that in the center of this planet, and we'll surround it with molten whatever lead, and that gives us some more mass, and we can so you can really go to town on creating this picture with the mathematics that has branched from one thing, the fact that something will fall through the air at a certain rate of speed, and then comparing it with the time that we see it takes for a star or a planet to move across the sky or do an orbit, and there you have your heliocentric model. And that's all it is. It really is just a model. So ultimately, does having a pressure gradient prove the globe or the flat Earth? No, neither. It's just, it is how it is, and it's no different to what we see happening, or we can at least measure on Earth with pressure, is no different to, for example, someone being in a pylon where loads of people are piling on top of you, and of course you feel all the pressure of the people on top of you, their weight, their mass, and you're all in the medium of air. The person on top isn't going to feel any pressure. So you can downsize that or upsize that as much as you like to have your thought experiment. And I just find it incredible, really, when, for example, you talk about how the oceans, the massive oceans, the gazillions of tons of water somehow gets held onto the Earth. And of course the answer is that the more mass something has, the greater force of gravity it has. But again, it's just talking about weight. Of course, the more mass something has, the more weight it has. More weight, more gravity. It still does not dictate or determine or prove in any way, shape or form that there is an external force coming out of the ground and pulling everything towards it. It still doesn't have to be that way. It's just a perception of the mechanics of it that hasn't been proven, because you simply cannot measure the force of gravity coming out of the ground all on its own. You need another mass, and you don't measure the weight of the mass, but you measure the time it takes to fall through the air to determine gravity. But how fast do you expect something to fall through the air? There's got to be a limit. There's also terminal velocity to consider. We don't know what happens to something if you drop it for 10 miles. We've never done that. Does it speed up for eternity, or does it reach a terminal velocity? It's not something we've ever been able to do. So of course we can make calculations and say, oh, it's just going to accelerate, continue getting faster and faster at 9.8 meters per second, but we don't know if there's a limit to that, or why it should or shouldn't drop any faster or slower. Yeah? So it's just that once something's denser than its surroundings, and it is a fixed mass, it will drop. Boom, like that. It's a little bit different with a helium balloon, because it's actually a mass that's comprising of a gas. So the interaction between the gas and the medium around it, which is also going to be a gas, will be a little slower than simply that. Even if that balloon, for example, a helium balloon, is rising up, then the rate of acceleration, or the speed that it rises up, will not be as dramatic as dropping a marble through the air, because the marble is so much more denser. It's already breaking that density. And of course you can just have to consider what happens to things once they hit the water. They slow down, there's resistance, and of course it is well understood that you have this force apparently making everything, creating the pressure, but it doesn't mean anything towards what's creating that force. As I said, it's just an internal force of the combined mass, the mass creates the force inside of it. You don't need an external force to push it down or pull it down. Yeah, and there is no pull in nature anyway. Everything's push. So to some extent, the pressure keeps us on the ground as well. Yeah, and whether there's a lid on it or not, and what that lid is made of is anyone's guess. Absolutely anyone's guess. So we all know what we are taught to assume or believe as the way it works. That's all understood. The model is understood for the globe. But the fact that there is a pressure gradient doesn't really mean anything. Not one thing really as to the shape of the Earth or how gravity is created. On a fundamental level, it's just relative density in layer upon layer upon layer upon layer. And as for what's underneath the Earth or above, who knows? So there's obviously a limit to where we can go above the Earth. What's above that, nobody really knows. And the Earth itself could be floating on very saline water. We could just be some kind of island in a pond. Of course, it doesn't matter how far you extend your thinking, because you're going to think that, well, the water has to be contained. Well, yes, if the Earth is just floating on water or something like that, then it has to be contained. Ultimately, doesn't it? But you can have that in another container and another container. But the conundrum doesn't take us any further than the idea of infinite vacuous space. That only solves an extra step in the perception of where we are in the universe. We still have no clue. We still can't really imagine an infinite universe. And besides, where did it all come from anyway? Where did any of this come from? The earth, the gas, the water, all that. In fact, you'll find that all the elements we need for creating a solid earth are probably this soluble solution that's in water. But we don't know. We don't know where it comes from. There's talk of stars creating water, spurting out water. Well, that may be the case, but the distance to those stars and what they are is clearly still a great mystery. So, yeah, it's a bit of a one-sided thing, but really I see people having endless debates about the pressure gradient, but the crux of the issue is that there's no proof of what actually creates it. And it can't be used as an argument for either side, really, except that we know that if we get a fish tank or something and we put water in it, then the dense water replaces the air that was in there, and so on. We can create these layers, and of course it has to be contained. The moment you don't contain water, then it will just spread out, and you can't create columns of water with the idea that down is towards the center of a spherical Earth, or that gravity is pulling everything down towards the center of a spherical Earth. Otherwise, the physics might well be different. You might well be able to make columns of water, just stack them up without any container. But ultimately, no matter how far out your thinking goes in terms of what space is and where the Earth is in the universe, we still cannot perceive, believe, or understand, or know the limits of any of this. The Earth, the sky, space, whatever. It's beyond our comprehension. So there's no harm in us realizing that we haven't got it all worked out, and that we were given a nice theory that seemed to be a working model per se. But again, all we're looking at is the passage of time, and throughout millennia, different cultures and different people have studied the stars and marked the passage of time, and they still do today. But none of them ever needed a heliocentric model in order to do that, or make predictions about eclipses and where stars will be, etc., etc. Never a model was never required. The only thing that was done was things were recorded, and this repetitive pattern was seen, and there you go. You have predictions that can be made. Not based, so it's, predictions are not exclusive to the heliocentric model. It's often used as an excuse. Not at all, not at all. So in summary, what do we have as far as observable facts? Well, first, pressure gradients exist in gas and liquid mediums on and above the Earth, to the limit that we can observe, which is anywhere between 1,000 and, we are told, 10,000 kilometers. Masses rise or fall depending on their density relative to the density and pressure of the medium that they are in. This is all we can observe as a fact. The cause is simply putting a mass into a medium. So if you have a dense mass in a less dense medium, that mass will fall. No external force required. If you put a non-dense mass, such as a helium balloon, in a denser medium of air or water, then it will rise. Again, there is no external force required other than the relationship between the mass and the medium. So we don't have any other proof of the cause other than introducing a mass into a medium, and we then get an observable phenomenon. We get a result, a cause or an effect, because of the cause that we created or was created by putting a mass into a particular medium. That's it. To go beyond that is to assume. And we can artificially change the density or the pressure of a medium, but this requires a solid barrier, as we see with vacuum chambers, etc. Now, gas and liquid mediums are slightly different because gas can be compressed, but liquid or water cannot be compressed. You can put it under pressure, but you can't squeeze water into a smaller container than it will exist. And of course, containers are required to contain gases and liquids. This is just, again, an observable fact. Now, of course, it's understood that we can assume that you take something out of the container and it gets pulled towards the center of a spherical Earth, etc. But as far as we can perform any kind of experiment on Earth, gases and liquids have to be contained. So you can't make a column of water because water cannot support itself, regardless of any ideas of gravity. So you need a solid container for any kind of measurement or experiment or test of a medium, or that then becomes a mass. A medium that is contained, a water or a gas that's contained, then becomes a mass. And pressure is a constant horizontally. Displacement often comes into the argument when For example, you put something into water and that water is in a container, then you're going to get displacement, so the water level rises simply because the object that you introduce is taking up space that would be filled by water, and the water can't go anywhere else, can't go sideways, it can only go up. So in this respect, up and down is created within a contained environment, because pressure doesn't change on a horizontal level, but it will change on a vertical level. And that's just a natural result of something being contained. So again, we're talking about cause and effect. By introducing something into a contained medium, then we create an effect of displacement. And pressure gradients, layers of density, occur, as we said, in containers. In fact, if we compare liquids or liquids in free fall, they become mixed up. It's only when they are settled that they then become layers. So if we look at what we see on the Earth, we see layers of density, liquids, water, gases. It's all in layers, and they are affected by certain other external forces. However, we are told that we are on a globe that's spinning and falling through space at incredible rates of speed, yet we do not see the same kind of effect on liquids that we do when we drop liquids in free fall. So what does that say? That just tells us straight away that the Earth isn't moving, the Earth isn't falling through infinite space. Otherwise, everything, all the liquids on the Earth would not settle in layers of density. Nothing would settle, everything would be floating. But of course, this is why you need the idea of gravity, to hold everything down onto this sphere as an external force. But again, the Earth is said to be falling around the sun and spinning at the same time at a rate of speed or acceleration that is much faster than 9.8 meters per second squared. So gravity couldn't keep up anyway. The alleged force of gravity couldn't keep up with the alleged motion of the Earth in the globe Earth model. So it's not logical or scientific in that respect. So what fundamentally causes pressure gradients is placing gases and liquids in containers. And what do we observe or measure? We measure relative density. We observe relative density. That's it. We do not measure any external forces from anywhere else. Now, when we talk about the difference between measuring weight and gravity, they are, of course, the same thing, but they have been separated in the description. The descriptions or the ways of measuring them have been separated. However, they are put together. Weight and gravity are really the same thing, but they are measured in different ways, because we have the definition of gravity being weight. But weight is a physical force, something being weighed on scales and measured in kilograms or pounds. And you can even measure it in newtons, which is just 9.8 newtons is the same as 1 kilogram. And that is simply because the way gravity, or globe Earth gravity, is measured is because of this rate of acceleration as something falls through the air. So this is a translation of the time and it takes to travel, for an object to travel a certain distance, and translated into a physical force. But they are two different things. They're measured in different ways, but all lumped into the same formula with F equals ma. And so we know that usually we require an external force to push something along. So this leap of faith is made that something falling also requires an external force, or these two different ways of measuring the weight of something on a scale or the rate of acceleration that something falls have both been attributed to an external force and combined into a single equation to make that connection with the way things fall on the Earth to us being another planet falling through the sky. So the measuring of weight is just mass. Weight is measured as a constant downward physical force caused by mass at rest in the medium of air. That's where the measurements start. They start in the medium of air. So once a mass goes into water, then you already have your starting point of the medium of air, and you make your calculations off that. But what if we were in a completely watery environment? Then the measurements would start with masses in water, but we use air as our foundation for the measurements, masses in the medium of air, because that's the medium that we exist in. So weight is measured in kilograms, pounds, or newtons, as we've discussed. But when you measure weight, no measurement of time is required. No measurement of speed or acceleration of that mass is required, although it's assumed that the mass is still trying to accelerate towards the center of a spherical Earth. It's actually not doing anything. It is at rest. So no external force is required for measuring weight. But when it comes to measuring gravity in globe terminology, it's a measure of this downward acceleration, distance traveled over time, of any dense mass through a less dense gaseous medium. It's not a measure of physical force. It's a measure of a falling mass that's not at rest. So weight is measured with a mass that's at rest. Gravity is measured with a falling mass in motion. Two different things, but again they are lumped into the same formula. F equals ma, force equals mass times acceleration. Hence the confusion. Hence the inability to separate the two, or the assumption that things falling on the Earth are connected to the way we see the sun, moon and stars and perceive the Earth as being another body of mass falling through infinite space with everything else. It's just an assumption. It's not anything that can be physically measured. So we have these assumptions of gravity and the problems for the globe model. So it's assumed that an external force is selectively pulling everything to the Earth, but that cannot be scientifically measured. You cannot measure any kind of force just coming out of the Earth. The heliocentric globe-Earth model also assumes that the Earth is a specific spherical mass. But this is something that can never be properly, physically, scientifically measured. It can be calculated for a model, a mathematical model, but it can't be measured. We can't measure the weight of the Earth as a mass as we would do by putting a weight on a pair of scales. Simply can't be done. You can't weigh the mass of the Earth. So the whole entire globe, Earth, heliocentric model is one interpretation of observations, of which there are many possible interpretations, but deciding to put the sun at the center, and also assuming that the Earth is a body with a specific mass, and it's just another planet, of which those also have mass, and they're all falling through infinite, endless, vacuous space. Just to describe or explain the model, not with science, not with physics, but with mathematical descriptions. And sometimes they're not even mathematical, they're just explanations. So these explanations are not scientific. They're not backed by any measurable proof. And that is the problem. We have a model that is nothing more than pseudoscience when you compare it with real science and what can or cannot be physically measured or scientifically measured as to the cause and effect. It's really very, very simple, but it requires these long, drawn-out explanations and highlighting examples and comparisons in order to understand that the heliocentric globe Earth mathematical abstract model has been passed off as science, when it's not, it's just pseudoscience. Science is the measure of our physical reality. And if we cannot determine or measure or test or prove the cause of an effect or an observation, then anything that assumes or attempts to describe or explain the phenomenon without any physical measurable proof is pseudoscience. And this is where we have to use our discernment. So, to conclude, does having a pressure system or layers of density prove that we're on a globe? Of course not. And it shouldn't even be used as any kind of argument by anyone who has the slightest bit of discernment. I hope that helps. Thank you for listening and allowing me to share. Of course, people are going to comment, and they're going to make comments based on the preconceived model of the globe Earth heliocentric system. They'll be ignored. It's been explained. That's just up to you whether you'll take it into consideration, contemplate it, and maybe come to the realization that we have been literally brainwashed to believe and have faith that something as simple as dropping an object on the Earth has been converted into this religion of scientism, of which gravity is the all-seeing, all-knowing, omnipotent, omnipresent God. Thank you very much.